Hello everyone, this is Mr. Mola for lesson 8-2, graphing f of x equals ax squared plus c. So you'll notice the big difference from yesterday's lesson to today's lesson is that plus c there. So yesterday we looked at problems with ax squared, so we were looking at the stretch and the shrink. Now today we'll be looking at the stretch and the shrink and also then the plus c, which if you remember from last time, makes the graph either go up if it's positive or down if it's negative. So if we're looking at a here, I'm just going to plug it into Desmos here so we can see what it looks like there. So we already have the x squared, so y equals x squared, and then we have the x squared plus 2. So pretty much the same kind of a graph. Not one's any shorter or fatter or taller or skinnier than the other one. They would be exactly the same if I got rid of that plus 2. Look, disappears. But that plus 2 makes the whole graph shift up 2. So for this one, we would go and write it is a vertical shift, or vertical translation, up 2 because of the plus 2. Okay, same thing here. B, it wants us to compare 2x squared and 2x squared minus 2. So kind of the opposite. So let me put a 2 in front of that. So 2x squared and then 2x squared minus 2. So again, red line is what we're starting with, and then down to the blue line, not any skinnier or fatter, but the blue line is 2 units down from the red line. So same thing. This one is a vertical translation. Two down. And then there's some questions on the homework that'll throw both of them at you, where they'll be asking for the slope, or sorry, the stretch or the shrink. And then they'll also be asking for the translation up or down. So like here, if you look at number 1, it wants us to compare it to x squared. So this one is just x squared, so it's not going to have a stretch or a shrink, but it is going to have a plus 5. So that vertical translation makes it go up 5. Here it has x squared minus 3, so x squared doesn't change, but the minus 3 does make it change, and it's going to go 3 down. And then remember, if we wanted to graph these to kind of see what they look like, we do the same thing we did yesterday. So I pick 3 numbers, probably 0, or negative 1, 0, and 1. So negative 1 squared is 1, 1 plus 5 is 6, 0 squared is 0, 0 plus 5 is 5. And 1 squared is 1. 1 plus 5 is 6. So then if I was making my table here, then my graph, I'd go negative 1, 6, which is off the graph. I should have went lower. And 0, 0, and 1, 6. I'm sorry, 0, 5. Not 0, 0. So it's going to look something like that. Now if you look at 3 and 4, now they get into these ones that have a stretch or a shrink here. So this one, first of all, is negative, so then it would be a reflection over the x-axis. This one will have 3 things in it then. So 1, reflection over the x-axis. 2, there's a 3 there, so it's going to be a stretch of 3. And then there's that minus 2 there. And so it's going to go 2 down. Okay, and then similar to here, we have a 1/2, so it's not negative, so we don't have to worry about the reflection part. But since it's 1/2 and it's less than 1, that means it's going to be a shrink of 1/2. And that minus 4 is going to make it go 4 units down. Okay, here they want us to find the 0, so kind of going back to chapter 7 when we did some factoring and foiling. So first I'm going to pull out a negative there. So that makes this problem a little easier. So I have x squared plus 1. So if I want to break that up, I'm going to do x plus 1 and x minus 1. And now we're finding the zeros. So that means pretty much set it equal to 0. So x plus 1 equals 0. So subtract 1 from each side. So one answer is negative 1. X minus 1 equals 0. So add 1 to each side. So x is positive 1. So 2 answers there, negative 1, positive 1. Very similar to what we did last time. And then if I look at like number 8, so negative 9x plus 1. So again, I'm going to factor out a negative there. Okay, and so the way I'm going to get to 9 is 3x plus 1 and 3x minus 1. And same thing, we're going to set that equal to 0. So 3x plus 1 equals 0. So subtract 1. So 3x equals negative 1. And then divide both sides by 3. So one answer is negative 1/3. And then same thing on the other side with the negative, or with the subtracting 1. So it's a subtracting 1, so I'm going to add 1. So 3x equals 1. Divide both sides by 3. So positive 1/3 and negative 1/3. 9 and 10, they want us to sketch the problem. So they want to see what would it look like. So they give us a couple of clues here. So a parabola opens down. Okay, so we're looking for a graph that opens down and has a vertex of 0, 5. So 0, 1, 2, 3, 4, 5. So that's going to be our vertex. And it opens down. Doesn't say anything about our slope or anything. So we're just going to do a parabola that opens down. Doesn't say whether it stretches or shrinks. But that's all we know about that graph. So that's all we can graph. Then kind of similar there on number 10. So the lowest point of the parabola is 0, 4. So that tells us that there's a point there, and that's the lowest point, so that means everything has to be above it. So that it has to be going up there. All right, I think you have one of these on your homework talking about how things fall. So the function f of t equals negative 16t squared plus s to the 0 power represents the approximate height in feet of a falling object after t seconds. So how fast does something fall? So it falls at 16 feet per second until it hits terminal velocity. Okay, and then a tennis ball falls from a height of 400 feet. So I'm going to put that 400 in for that s there. So I have negative 16t squared plus 400. And we want to know when it hits the ground, and the ground is at 0 feet. So I'm pretty much solving for t. So I'm going to subtract 400 from each side. So I have negative 16t squared equals negative 400 now. We're going to divide both sides by negative 16. And negative 400 divided by negative 16 is 25. And so now I have t squared equals 25. The opposite of squared is square root. So then we find out that t equals 5 or negative 5. Except in this case, negative 5 doesn't really make sense because you can't have negative 5 seconds. So after 5 seconds, if you drop a tennis ball from a height of 400 feet, it's going to hit the ground. Okay? And then B says, what happens if you drop it, or if the height is decreased by 384 feet? Well, you started at 400 feet, and now if you decrease it 384 feet, well, that's really just dropping it from 16 feet. So now you're dropping it 16 feet off the ground. And some of you might already know the answer to this because something falls at 16 feet per second, so you could probably figure out what the answer is. So negative 16t squared equals negative 16t. Divide, divide. So you get t squared equals 1. And then same thing, square root both sides to get rid of the square. So you're left with t equals positive 1 and t equals negative 1. But again, negative 1 doesn't make any sense because you can't have negative 1 second. So if you drop a tennis ball from 16 feet up in the air, it will take 1 second to reach the ground. So if you're somewhere less than 16 feet up in the air and you drop a tennis ball, it's not hitting the ground, or it'll take less than 1 second for it to hit the ground.